Don't make unnecessary journeys. Don't take risks on treacherous roads. And don't swim in the sea.
What if I told you that the weather isn't natural? That every raindrop, every gust of wind, every ray of sunshine is controlled by shadowy figures pulling strings from behind the scenes? Sounds crazy, but what if it's not just a conspiracy theory? What if it's science? Welcome to Neurodium. Today we're diving deep into the world of geoengineering, where science fiction meets reality, and the fate of our planet hangs ominously. Imagine a world where governments can control the climate like a thermostat. A world where droughts can be ended with the flip of a switch, where hurricanes can be steered away from populated areas, where global warming can be reversed. This isn't the plot of a summer blockbuster. This is the promise of geoengineering. But as with all promises that sound too good to be true, there's a catch, a big one. We're talking about playing God with the planet's climate. And if we get it wrong? Well, let's just say the consequences could be apocalyptic. So, buckle up. We're about to embark on a journey that will challenge everything you thought you knew about the weather, the climate, and the future of our planet. Let's start at the beginning. Geoengineering isn't some new, fringe concept. It's been around for decades, hidden in plain sight. Remember those old movies where the military tries to control the weather? Turns out, that wasn't just Hollywood fantasy. Back in the 1960s, during the Vietnam War, the US military launched a top-secret mission called Operation Popeye. Their goal? To extend the monsoon season and quite literally rain on the enemy's parade. They seeded clouds with silver iodide, creating artificial rainstorms that turned supply routes into muddy quagmires. This wasn't just tinkering with nature. This was weaponizing the weather. But Operation Popeye was just the tip of the iceberg. Throughout the Cold War, both the United States and the Soviet Union poured resources into weather modification research. The dream of controlling the weather was seen as the ultimate strategic advantage. Imagine being able to flood your enemy's farmlands or freeze their troops in the field. In 1978, the United Nations stepped in, banning the use of environmental modification techniques for military purposes. But the research didn't stop. It just changed direction. Fast forward to today, and geoengineering has evolved from these crude beginnings into a sophisticated field of study. Scientists are now proposing grand schemes to cool the entire planet. But before we get to those, let's break down the basics. Geoengineering falls into two main categories: solar radiation management, SRM, and carbon dioxide removal, CDR. Think of SRM as putting the Earth under a giant sunshade, while CDR is more like giving the planet a carbon dioxide vacuum cleaner. Let's start with SRM, because this is where things get really wild. Imagine a fleet of aircraft constantly spraying reflective particles into the stratosphere. These particles would act like tiny mirrors, bouncing sunlight back into space before it can warm the Earth. Sounds like science fiction, right? Well, it's not. This technique, known as stratospheric aerosol injection, is being seriously considered by top scientists. One of the leading voices in this field is Dr. David Keith from Harvard University. He's been pushing for small-scale experiments to test the feasibility of stratospheric aerosol injection. His project, called ScoPex, aims to release small amounts of calcium carbonate dust into the stratosphere from a high-altitude balloon.
The basic idea of solar geoengineering is the idea that we could partially and imperfectly reduce some of the risks of climate change that come from the accumulation of greenhouse gases in the atmosphere by putting reflective aerosols, say sulfuric acid, a pollutant, in the stratosphere where it would reflect away a little bit of sunlight, say 1% at the peak. That's really the core idea. And this idea has a kind of terrifying leverage in the sense that a gram of these aerosols in the stratosphere roughly offsets the climate force, or forcing, as we say, of a ton of carbon dioxide in the lower atmosphere. It doesn't eliminate the problem, but it masks some of it. And that's a ratio of 1,000,000 to 1, kind of like the ratio of chemical weapons to nuclear weapons. Because that scale of thing that we're dealing with, for better, for worse.
Now, you might be thinking, isn't pumping particles into the atmosphere what got us into this climate mess in the first place? And you'd be right to be skeptical. The idea behind stratospheric aerosol injection is to mimic the cooling effect of large volcanic eruptions. When Mount Pinatubo erupted in 1991, it pumped millions of tons of sulfur dioxide into the stratosphere. This created a haze of sulfuric acid droplets that cooled the Earth by about 0.5 degrees Celsius. Scientists like Keith want to recreate this effect, but in a controlled, reversible way. But here's where it gets complicated. The Earth's climate system is incredibly complex, with countless interconnected processes. Mess with one part, and you could set off a chain reaction of unintended consequences. Critics argue that we're opening Pandora's box. What if these particles damage the ozone layer? What if they change rainfall patterns, causing droughts in some areas and floods in others? And perhaps most terrifyingly, what if we start doing this and then suddenly stop? The rapid warming that could follow, a phenomenon known as termination shock, could be catastrophic. Stratospheric aerosol injection isn't the only SRM technique on the table. Some scientists have proposed an even more audacious plan: space mirrors. The idea is to launch a swarm of reflective satellites into orbit, creating a solar shield around the Earth. One of the most ambitious proposals comes from astronomer Roger Angel. He suggests launching trillions of small, transparent disks into space. These disks would be positioned at the L1 Lagrange point, a spot between the Earth and the Sun, where the gravitational pull of both bodies is balanced.
American scientists reportedly want the final version of the report to recommend new technologies called geoengineering. One idea, for instance, would use giant mirrors to deflect some of the sun's rays from getting to the Earth, cooling the planet back down. Sounds like science fiction. With NASA funding, University of Arizona professor Roger Angel is researching using small disks to create a giant sun shade in space.
The effect could be to take our temperature back to pre-industrial level.
The scale of this project is mind-boggling. We're talking about a cloud of disks covering an area roughly the size of Brazil. The estimated cost? A cool $5 trillion. It's like something out of a Bond villain's playbook, but it's being seriously discussed in scientific circles. Now, you might be thinking, this all sounds pretty far-fetched. Are there any SRM techniques that are more down to earth? Well, funny you should ask. Let's talk about marine cloud brightening. The idea here is to make clouds more reflective by spraying seawater into the air. The salt particles in the seawater would serve as nuclei for water droplets to form around, creating brighter, more reflective clouds. It's like giving the Earth a white, reflective hat to keep it cool. A team at the University of Washington has been working on developing spray systems that could be mounted on ships. These ships would cruise around, spraying a fine mist of seawater into the air, creating brighter clouds in their wake. But here's the catch, and you might be noticing a pattern here. We don't fully understand how this would affect weather patterns. Could we inadvertently cause drought by redirecting rainfall? Could we disrupt ocean ecosystems by altering the balance of sunlight reaching the sea surface? Now, let's turn to the other side of geoengineering: carbon dioxide removal. This approach aims to tackle the root cause of global warming by sucking CO2 out of the atmosphere. One of the most promising techniques in this field is direct air capture. Picture giant fans drawing in air and passing it through a chemical solution that absorbs CO2. It's like giving the Earth an artificial lung. Companies like Climeworks in Switzerland and Carbon Engineering in Canada are already operating pilot plants using this technology. The Climeworks plant in Iceland, called Orca, captures about 4,000 tons of CO2 per year. That might sound impressive, but to put it in perspective, humans emit about 40 billion tons of CO2 annually. But direct air capture isn't the only CDR technique on the table. Let's talk about a method that sounds like it's straight out of a sci-fi novel: ocean fertilization. The idea is simple. Dump iron into the ocean to stimulate the growth of phytoplankton. These tiny marine plants would then absorb CO2 as they grow, and when they die, they'd sink to the ocean floor, effectively sequestering the carbon. It's like turning the oceans into a giant carbon sink. Sounds simple, right? Well, in 2012, a controversial experiment off the coast of Canada showed just how complicated and contentious this can be. The Haida Salmon Restoration Corporation dumped about 100 tons of iron sulfate into the Pacific Ocean. They claimed it was to restore salmon populations, but many saw it as a rogue geoengineering experiment. The incident sparked international outrage and highlighted the need for clear regulations on geoengineering. It also raised some serious questions. What would happen to marine ecosystems if we start tinkering with the base of the food chain? Could we inadvertently create massive algal blooms that deplete oxygen in the water, creating dead zones? Some scientists have proposed an even more radical form of ocean-based carbon sequestration: deep-sea carbon storage. The idea here is to pump liquefied CO2 into the deep ocean, where the intense pressure would keep it in a liquid state. Over time, this liquid CO2 would dissolve into the seawater or form solid compounds on the seafloor. It sounds like a neat solution, but there are serious concerns. What would this do to deep-sea ecosystems, which we still know very little about? Could it lead to ocean acidification on a massive scale? Now, let's shift gears and talk about a CDR technique that's a bit more down to earth. Literally. I'm talking about enhanced weathering. Weathering is a natural process where certain rocks absorb CO2 from the atmosphere as they break down. Some scientists propose to accelerate this process by grinding up these rocks and spreading them over large areas of land or sea. One of the most promising materials for this is olivine, a common mineral that's particularly good at absorbing CO2. The idea is to grind olivine into a fine powder and spread it on beaches or farmland. As it weathers, it would absorb CO2 from the air and eventually wash into the ocean, where it could help counter ocean acidification. It sounds great in theory, but there are practical challenges. We'd need to mine, grind, and transport enormous quantities of rock. We're talking billions of tons per year to make a significant impact. The energy required for this could potentially offset some of the carbon sequestration benefits. But here's where things get really interesting and scary. While scientists debate the merits and risks of these technologies, some governments are quietly pushing ahead with their own geoengineering programs. China, for instance, has the world's largest weather modification program. They routinely seed clouds to increase rainfall, and they're not shy about their ambitions.
In China, they're waging war on the weather. A drought so severe, they're firing rockets into the sky to make it rain. The practice is known as cloud seeding. Drones and rockets are used to sow silver iodide into the clouds. The substance has a similar structure to ice and changes the cloud's structure to increase the chance of rain. After more than 2 months of extreme heat, it is desperately needed.
Right now, we are rather sufficient in our artificial influence rocket supply. We have strengthened monitoring of the weather and carried out artificial precipitation operations accordingly to further relieve the drought and high temperature in the area.
But here's the thing: weather doesn't respect national boundaries. What happens when one country's rain comes at the expense of another's? This brings us to one of the most chilling aspects of geoengineering: its potential to spark international conflicts. Imagine a world where superpowers compete not just for land or resources, but for control of the climate itself. It's not hard to see how geoengineering could become the ultimate geopolitical weapon. And it's not just China. In the Middle East, the United Arab Emirates has been conducting hundreds of cloud seeding operations each year. In a region plagued by water scarcity, the ability to squeeze more rain from the clouds is incredibly valuable.
UAE is planning to seed clouds. Well, in short, it's going to produce artificial rain. Scientists are using new technology to create clouds. The country is now making an effort to seed clouds and increase precipitation. United Arab Emirates meteorological official Abdullah Al Hamadi has said that cloud seeding increases rainfall rates by approximately 10 to 30% per year. Aircrafts would first take off dozens of salt canisters attached to its wings for the formation of these clouds. The plane then would release salt flares into the most promising white clouds, hoping that it will trigger rainfall. Aircrafts will shoot hygroscopic or water-attracting salt flares, releasing salt nanoparticles into the clouds. This would stimulate and accelerate the condensation process. Ultimately, this is what will produce rain. Although UAE for long has been adopting desalination process, which is making use of seawater or ocean water, now this can now be an expensive affair to, in fact, seed clouds to trigger rain. The process of seeding clouds is again not an easy one. It's quite intense for pilots, definitely not a cakewalk to seed clouds 9,000 feet above sea level. In fact, cloud seeding is considered the second hardest challenge for pilots, as per one official. I'm going to quote that official here. He said, "When there is a cloud, we try to figure out the way we need to go in and out of it and avoid thunderstorms and hail." Certainly not easy then.
But again, we have to ask, what are the long-term consequences of messing with regional weather patterns? Now, let's talk about a country that's been at the forefront of climate research, and, some would say, geoengineering, the United States. While the US doesn't have an official geoengineering program, it has been funding research into various geoengineering technologies. The National Oceanic and Atmospheric Administration, NOAA, has been studying the effects of aerosols on climate for years. But perhaps the most controversial US project is H.A.A.R.P, the High-Frequency Active Auroral Research Program in Alaska. Conspiracy theorists have long claimed it's a weather control weapon. It's not. It's a research facility studying the ionosphere. But the idea of using technology to manipulate the atmosphere, that's precisely what geoengineering is all about. H.A.A.R.P uses high-power radio transmitters to heat up small areas of the ionosphere. The stated goal is to study the physics of the ionosphere and develop new communication technologies. But some researchers have speculated about its potential for weather modification. Now, I know what some of you are thinking. This all sounds like a bunch of crazy conspiracy theories, and you're right to be skeptical. The internet is rife with wild claims about weather control and chemtrails. But here's the thing. While many of these conspiracy theories are baseless, they often contain a grain of truth. Take chemtrails. The idea that the government is secretly spraying us with chemicals from aircraft is nonsense. But the concept of deliberately releasing particles into the atmosphere to affect the climate, that's exactly what stratospheric aerosol injection proposes to do. Or consider the long-standing rumors about the US military's weather control programs. While there's no evidence of a current weather warfare program, we know that such research did take place in the past. Operation Popeye, which we discussed earlier, is a prime example. The line between conspiracy theory and cutting-edge science is often blurrier than we'd like to admit. And in the case of geoengineering, today's fringe idea could be tomorrow's global policy. But it's not just governments we need to worry about. As geoengineering technologies advance, there's a real risk that private entities could get in on the action. Imagine a billionaire deciding to cool the planet single-handedly. Consequences be damned. It sounds like the plot of a dystopian novel, but it's a scenario that keeps many scientists up at night. In fact, there have already been instances of rogue geoengineering experiments. Remember the ocean fertilization experiment off the coast of Canada we mentioned earlier? That was largely funded by a single businessman who believed it would help restore salmon populations. While his intentions may have been good, The incident highlighted the potential for individuals to carry out large-scale environmental manipulation without proper oversight. This brings us to a crucial point. How do we regulate technologies that could affect the entire planet? Who gets to decide if and when these technologies are deployed? Currently, there's no comprehensive international framework for governing geoengineering. The United Nations Convention on Biological Diversity has called for a moratorium on geoengineering activities, but it's not legally binding and doesn't cover all types of geoengineering. Some scientists and policymakers have called for a global geoengineering governance framework. This would set rules for research, testing, and potential deployment of geoengineering technologies, but getting all countries to agree on such a framework is a monumental challenge. And then there's the ethical dimension. Do we have the right to deliberately alter the Earth's climate? Proponents argue that we're already altering the climate through greenhouse gas emissions, so geoengineering is just a more controlled way of doing what we're already doing. They say that if geoengineering can prevent the worst impacts of climate change, we have a moral obligation to pursue it. Critics counter that geoengineering is a dangerous distraction from the real solution, reducing greenhouse gas emissions. They worry that the promise of a technological fix will reduce the urgency to transition away from fossil fuels. There's also the question of unequal impacts. Geoengineering could affect different regions in different ways. What if it helps some countries while harming others? Who would compensate the losers? As we grapple with these questions, research into geoengineering continues to advance. Scientists are refining models, developing new technologies, and pushing the boundaries of what's possible. For example, there are the researchers at Harvard that are developing the balloon system that could be used for stratospheric aerosol injection experiments. Also, there is that team at the University of Washington that is working on a ship-based system for marine cloud brightening. Even more so, in the field of carbon removal, companies are scaling up direct air capture technologies. Climeworks, which we mentioned earlier, plans to scale its operations to remove millions of tons of CO2 per year by 2030. And then there are the more speculative ideas. Some scientists have proposed using genetically engineered plants to absorb more CO2. Others have suggested using lasers to break up greenhouse gases in the atmosphere. The pace of innovation in this field is staggering, but as the technology advances, so do the stakes. We're rapidly approaching a point where large-scale geoengineering interventions could become technically feasible. The question is, will we be ready to handle the consequences? As we wrap up this deep dive into geoengineering, let's take a moment to reflect on what we've learned. We've explored technologies that sound like they're straight out of science fiction, space mirrors, ocean fertilization, and more. We've seen how these ideas have evolved from military experiments to potential tools for combating climate change. We've also grappled with the profound risks and ethical dilemmas that come with these technologies. The potential to cool the planet and mitigate climate change is tantalizing, but the possibility of unintended consequences is terrifying. As we look to the future, the debate over geoengineering is only going to intensify. Climate change is accelerating, and as the impacts become more severe, the calls for drastic action will grow louder. But we must approach this technology with extreme caution. The Earth's climate system is incredibly complex, with countless interconnected processes that we don't fully understand. Tinkering with it on a global scale could have far-reaching and unpredictable consequences. As we stand at this crossroads, with the power to reshape our planet's climate potentially within our grasp, we're faced with profound questions. Do we have the wisdom to wield this power responsibly? Can we develop governance structures that ensure geoengineering is used for the benefit of all, not just a privileged few? The answers to these questions will shape the future of our planet. And make no mistake, the clock is ticking. As climate change accelerates, the pressure to deploy geoengineering technologies will grow. We need to have these difficult conversations now, before we're forced to make decisions in the heat of a climate crisis. As we wrap up, I want to leave you with a thought. Geoengineering represents the pinnacle of human ambition and ingenuity. The idea that we could control the Earth's climate is a testament to how far we've come as a species, but it also represents a profound responsibility, one that we must approach with the utmost caution and humility. The decisions we make about geoengineering in the coming years and decades could shape the future of our planet for centuries to come. Will we use this power wisely, or will we unleash forces beyond our control? This is Neurodium, where we explore the edges of science and the frontiers of human knowledge. If you found this journey into the world of geoengineering as mind-bending as I have, hit that like button and subscribe for more deep dives into the unknown. Until next time, stay curious.
Incredibly, people have been spotted in the water here in Blackrock and Salthill both today and yesterday. Galway City Council say their actions are idiotic